Okay, great. Slides are moving at the appropriate speed, apparently on my end, hopefully the same as on your end. Okay, so before we had our technical difficulties, I was saying that we're going to go through basic structure of the POM. We're going to talk about how to configure version information. We're going to talk about how to configure some basic project information, at which point you should be able to rerun the site command and see a different site generated. We'll talk about some project properties, how to create our own, but also use some that are baked into Maven, and then some general build setting conversations. So as a quick review, we know that the Maven POM structure has an inheritance structure similar to Java's inheritance structure, where everything extends the quote-unquote super POM. So far, we have looked at examples that are direct descendants of that super POM, meaning they have only one parent. We could, within Maven, create multi-module projects, or we could create POM dependency projects where I would have basically children of my POM. That's a little bit beyond the scope of what we set out to accomplish today in the classroom, but it is in the PDF, so obviously go ahead and look at that, and if you have questions, as I mentioned before, email me or call me. If I were to look at that super POM, there are a bunch of different things that it configures. You may have a question about how does Maven know where the central repository is. Well, it's pre-configured in the super POM. Or you may have a question about how does Maven know about the Surefire plugin. Well, it's pre-configured in the super POM. So some of the stuff that seems like magic really isn't that much of magic, because it's pre-configured somewhere. From our perspective, it's maybe a worthwhile exercise when you're sitting in front of the television drinking a beer to look at the super POM's XML file, but on a practical day-to-day basis, you probably don't really need to know much about it. What we really want to know is, how does the super POM define a valid project object model? In other words, what does the super POM define as a project XML structure? And once we understand what that project XML structure is, then we can go ahead and override or customize the configuration of the POM to meet our project's needs. So when I look at that project element within my POM, the project element allows me to define general information about my project, but it also allows me, or the POM also allows me, to define things dealing with my build, project information, my continuous integration server, repositories. I can have different build settings, which means I could have a build defined for production, a build defined for test, a build defined for local, all within a single POM. And each one of those can have their own configurations and their own dependencies and their own modules and so on and so forth. But generally I have those 4 different areas. If I were to look at a well-baked or well-formed POM, you can see in the slide in front of you all the different configuration pieces that are available to me. And again, we said that the POM is defined as a project. So up at the top of my pom.xml file, there is the open project tag. At the bottom of my XML file, there is the closed project tag. And then in between there, we have this POM structured into logical groupings. Because we're working with a schema, obviously ordering does not matter unless it matters, right? In other words, I could put the basics at the bottom of my pom.xml as long as they are above the closed project tag. So order doesn't matter unless it matters, and hopefully that makes sense to you. So that's just a quick look at what is available. Obviously, something like build, for example, that is could be a very complex element. So build's going to have a bunch of different children element, allowing me to define separate builds based on the target, for example. Modules is another potentially complex element. I can have a POM defined as a multi-module POM, which means the POM relies on a couple other modules to exist. Dependency management, to be honest, is probably the second most complicated after build, where I specify dependencies and manage dependencies. But generally gives you an idea of what the structure looks like. So the question is, now that we understand that we can override SuperPOM's information and customize Maven to meet our project's needs, the question becomes, where should I do this customization? And we're going to say that you have basically 3 different options. They're not all great options, but you do have 3 different options. The first option is to go and modify the SuperPOM. So this is what I talked about before. You basically unbundle the jar file that you downloaded. You go find the POM dash whatever version.xml, modify the heck out of it, repackage and rebuild your jar, and now you've got a customized SuperPOM. The problem with this, while it works, the problem with this is that you have just customized your particular instance of Maven on your particular machine. So, you're, yes. Yep.
Okay, seemed like you dropped out.
Where did it drop out?
You said you have just modified your...
Yeah, so you've just modified your own instance of Maven?
Yep.
So it's not global, right?
Right.
The second option is to modify your project-specific POM. And this is going to be my suggestion that you guys adopt this convention. More than likely, you're going to check in that pom.xml file into Git or Subversion or something like that, right? And so if you check that configuration in, everybody gets the generalized configuration shared. So I would say that's the kind of suggested. The other one is that you could actually go into your own settings.xml file. So Maven, remember Maven's got its own working directory .m2. That's where the repository lives. But as a peer to the repository is this settings.xml file. So if I wanted to configure a repository, for example, and I didn't want to have that repository configuration in pom.xml, I could pull it up. I could refactor it up basically into the settings.xml. The challenge is that while I have defined what appears to be global settings for every single project, they're local to my machine, right? So if I'm going to use this settings.xml structure, I'll probably also want to check that into my source control mechanism. So just be aware of that. Okay, so because of that, as a class, we're just going to focus on the project directory pom.xml configuration, option number 2 there. So as a quick snapshot, this is where we are right now in our discussion. If you've been following along in the labs, right, we've got the basic hello world put together. We defined the group ID and the artifact. Remember, version and packaging were specified for us by Maven. I've got the artifact, or this example has the artifact dealing with the Mac, and then also remember that when we use the archetype create, it specified JUnit on our behalf. So that's kind of a current snapshot of where we are today. The question becomes, at some point in time, if I have a multi-level inheritance occurring in my POM configuration, the question becomes, how do I really know what my POM looks like to Maven? In other words, how do I really know what configuration information Maven is using for the build or Maven is using for the test? I guess I could go through and look at all of the XML files that are creating this inherited POM. That's obviously going to take time. Maven's thought about that and has created a plugin, basically, with a goal. The plugin is the help plugin. The goal is Effective POM. And Effective POM is going to show you all of the configuration that exists for your particular POM. So if I have multi-module POMs or if I have inheritance, I would use this to help me debug. Make sense?
Yep.
Okay, so I don't think we need to do a lab on that. It's just a command. You can figure it out. It's pretty straightforward. So let's talk about the basics. Now that we know there's those 4 areas that we can configure, let's actually do the configuration. The first area of configuration is what I'm going to call just the general container types of information, or the description of the project types of information. It's not dealing with things like how does the compiler compile correctly, or how does the build take a deviant path when I'm dealing with production. It's more just general project properties. All the configuration that we have done or that Maven has done on our behalf so far is in this general project realm. We have so far been talking about something that I call the UUID. It's the group ID, the artifact ID, the versioning, and the packaging for my POM. We've been talking about that as the unique identifier that is used when I either install or deploy or create a dependency between a project. Maven uses a slightly different term. It uses the term coordinates. That's fine. But the thing to recognize is that those 4 pieces of information together define that project coordinate. And this should not be a new concept to you because we've been touching it throughout the day so far. The only thing that may be new to you is this idea that I could reference a project based on its Maven coordinates using a colon delimited string. So I've got the group ID, the artifact ID, and then the version. Okay. As far as the packaging goes, you'll notice that doesn't show up in the coordinate string. But from a repository perspective, there is a difference between a coordinate that has a jar packaging versus a war packaging. So be aware of that as well. So in regards to versioning, we have not so far in this discussion, we have not created a version number. We have been using what's referred to as the snapshot version. And the snapshot version, for all practical purposes, just means that my project is currently under development. It's a moving target, in other words. At some particular point in time, I will want to change my version from the snapshot version to an actual quote-unquote release version. That's obviously up to you and your project and project roadmaps on when you do that. But the key thing to recognize is that as long as I have a snapshot version and as long as I install the snapshot version in my either local or remote repository, any other project that relies on my project will access the greatest, latest, newest build if it exists. Okay, so Derek could be building a jar labeled snapshot on his machine. I could be building a project that relies on his jar on my machine, and he's constantly changing the jar, so he leaves the version as snapshot, installing every time or deploying every time he makes an update. My project, because it relies on his snapshot of version, anytime I do any one of the compile, test, package type of life cycles, Maven's going to go look for a newer version of the snapshot. Okay, which makes sense knowing that snapshot means under development, right? But when I get rid of the word snapshot, and it's really that simple, I delete the word snapshot from my version, now Maven is going to be version dependent, meaning it will not look for a newer nor an older version of the release. It's going to look for the exact version. So the moment Derek changes his 1.0-snapshot to 1.0.1, right, he is basically telling Maven, from a dependency perspective, everybody needs to use 1.0.1. So there are some versioning tricks dealing with upper limits and lower limits. So I can go in and I can configure my dependency to say, hey, use anything that Derek produces that's 1.0.1 or greater, and then Maven will give me some kind of more dynamic access to a library if needed. So here's an example, right? I changed the version number. Change the version number to 1.0. As an interesting side note, if I had actually deployed or installed this artifact using the version 1.0-snapshot, and I haven't cleaned up my repository, and then I flip the version to 1.0 or 1.0.1, and I install it, what's going to happen is that the snapshot version will still exist in my repository along with the new version, right? So Derek could change, maybe this is good or bad, right? But Derek could change the version from 1.0 snapshot to 1.0 and not remove the snapshot version from the internal repository. If he doesn't tell me that, hey, I've rolled out a new release, I'm no longer using snapshot, I might be writing software against his old snapshot version because I didn't update my dependency on that. So just be aware of that. That's a slight little side note about make sure you clean up your repository every so often. So why don't you do this? Why don't you quick go into your POM, change the version, do a package, and then do an install. And you should be able to look at the repository and see both the snapshot version and the 1.0 version, or whatever version number you give it. So try that for a second, and then yell at me when you're done, and we'll continue on.
What? Edit. Yeah. I got port BI in Windows. Yeah, is this like the shitty line base?
Yeah.
Yeah, that should work. Oh my god. I think I've seen this since high school. Yeah. Better than VI. Yep. Okay, so anyway. Nice trip down memory lane.
You're going to close the whole window.
Yeah. So what do we do here?
Remove the snapshot. Yeah, change the version. And then you want to package, and then install.
Oh, yeah. Close this whole window.
So do a Maven package. And then Maven install. And then we just want to check the repository and see. That's a change point there.
Should be for this.
Yeah.
There we go.
And the old one was still there too, right?
Yep.
Okay.
So we should do a PM.
I wonder what that one is.
Oh, that's a good question. They won't like that.
Yeah.
Possibly you can put anything in there you want.
Mm-hmm. Wow. It didn't choke on any of the special characters.
Okay.
It didn't choke because of the encoding, or it's because
Well, that's actually a rather limited set of special characters.
Yeah.
I just sort of, whatever, figured it, but, no, I'll just, oh, this won't work because it's
Yeah.
a comment.
what about if you remove the encoding? Would that work?
Not
Should,
everything. What's that?
What about if you remove the encoding or UTF-8?
Oh, down there?
Yeah, would that work?
I believe that that's going to be passed on to things. I don't think it will impact anything.
Yeah, it looks like a system policy.
So what do we do here? We can't really pass, we can't say. That'll just go through the XML parser. Oh, I suppose we should ask. Version, no, so that's not valid XML either. No, see, that's still not valid. Alright, so,
What about if you declare a global variable
what's that?
with the version?
What do you
Do
mean, what's that?
percentage, then version percentage.
And then I think you do this down here.
Oh. Divide.
But there is not, forget. Yeah. Oh, no, it took it just set version percent. There's some other way you can,
We're doing it now with the with
Yeah.
subdivision. I'll see if the syntax.
What was it doing it? Oh, there it is.
Yeah.
See that? Those are versions and properties. So we could do this. And dot version like that. And then there it is.
Mm-hmm.
Right. Kelby?
Yes. Yes.
Okay, we're good.
You're good? Okay.
Yeah.
It's not super exciting, but at least you see it works, right?
Yeah.
Okay. Okay, so let's talk, now that we know how version works, let's talk about just some general project information. So Derek, just so you know, Derek and group, just so you know, I put you guys on mute. I was picking up some background noise. So project information is just textual information. It's not going to really affect the build, right? I mean, defining the name of your organization, defining who the developers are. It's more static information that's worthwhile from a site perspective, or you know, if I push this out, if I push the site out internally and directed people to look at the site for support needs, you would maybe want to configure this information. It's pretty straightforward to do. A couple examples. Again, order doesn't matter unless it matters when I'm dealing with a schema. I've got an example there for the organization. I've got an example there of the developer, and you also see I can specify the roles. So it's not like, the key thing to recognize here is it's not like Maven's going to look at this and say, oh, you know what, based on the user's ID of the machine where I'm executing, I'm going to take an alternate path because Kelby with the ID Zordra is a developer versus Jim, whose ID is Jim1, who is a system administrator. That's not the intention of this information. It's more from a reporting perspective, if that makes sense. Let's go ahead and talk about project properties. So basic information like that, it's just textual information, right? Project properties are a little bit more advanced. They're not, you know, overly cumbersome, hard to use advanced, but they are intended to help me simplify my POM. For example, if I have an environment variable defined at the system level, the OS level, instead of me replicating that environment variable within my POM, so now I have two different environment variables with the same value defined and managed in two different places, I can just within my POM, I can just leverage the operating system environment variable as an example, right? So these properties are a little bit more advanced. In other words, I could use them, I could query them at build time, or I could query them at package time to have an alternate path occur within my build. So you'll see that I have access to project properties. Project properties are properties that I define myself. Environment properties are OS level. System properties are Java system properties, so on and so forth. If you have worked with Ant properties, this should be pretty familiar to you. The language notation, if it's not familiar to you, is the bean shell notation, which is the same notation that's used in JSTL and JSP. So if I were to access the project properties like the group ID, artifact ID, so on and so forth, I would just start my reference with the word project dot and then whatever element within that POM I'm trying to access. Remember, I'm just grabbing the value, right? So it's basically gonna echo the value out into whatever configuration I'm trying to use. Next one is environments. Oops, skip 2 slides. Next one is the environment. So if I want to grab my operating system's path, for example, or my operating system's definition for the host name, and use that in my POM, I could do that. Good example here is that if I know the build host name for my my QA server, and I'm going to do a build on the QA server, I could create a build path in the POM tied to a host name and take an alternate path if host name equals, theoretically equals build QA server, or if host name doesn't equal QA server. Another one that's a little bit more practical maybe would be the system settings. System settings are basically the java.lang.system properties that I get. So if I wanted to, I could say, hey, take a different build approach if I'm on os.name equals Mac OS X or os.name equals Windows XP. So again, I can do some configuration based on those properties. In between the environment OS level properties and the Java system properties, I have the Maven settings. And the Maven settings, I can access those within my POM just using the settings word. Last but not least is the project properties, or what I would call the user-defined properties. These are properties that I am defining either in my settings.xml file or in my pom.xml file. And all that I'm trying to do is I'm trying to define something once in my POM so that I can use it in other elements that I just declare or configure within my POM. So here's a real basic example. I create a properties element. I specify a new property called company URL, give it a value, and then I could go ahead and reference that, for example, throughout my POM. So you'll see right here I define company name, I define company URL, but you'll notice up here I go ahead and reference company name. Up here I reference company URL, so on and so forth. Okay, so that's just a simple way for me to define kind of project-oriented properties. It does not have to be as simplistic as just a textual string, right? But it's easy to illustrate. So with that, I'm going to suggest that we do a quick little lab. The configurations that we've talked about will definitely show up when you recreate the site. So take 10 or 15 minutes or so just tinkering with a few of those project properties or OS properties, then rerun the site and see if you can get the output to change or the documentation to change based on your property values, if that makes sense.
Okay.
So I'd say, are you? Let me quick ask first. Are you guys okay if we go a little bit long today, 15, 20 minutes long?
Yeah. Yes.
Yeah. Okay.
Yeah, that'll be about 4:20, 4:30.
Yeah. Yep.
So if we do this, and then we'll do the local host somewhere in here. Is the system property? Yes, it is implying that.
Yeah, there should be a
Maybe project summary.
well, there's the version.
Yeah, that was,
Yeah.
should be some property in here. Kelby?
Yes, this is me. I'm back.
Where in the In the web page, can we find the project property?
So like if you set up if you identify the team, like call out a developer in your POM, and then do site, that team section should now theoretically be filled in.
Oh, and fill it in with a variable.
Right, and then you can take that a step further. Once you know that works, then you can take that a step further and say, you know, this site was built by Kelby on, and then grab the host name or something like that, or the OS name or something like that.
Okay. So this is going back to that, what was it called? The developer.
Yeah, that's fine. You have it? Find it on?
Just search for developer.
For the information organization.
It's nothing. I think the terminal window there has a folder. I don't think this is. You know, open up the go to the terminal and say export. Oh, you have to compose the other two. Yeah.
Very good to copy.
Yeah.
Right.
So what?
Oh, the site?
Yeah. Yeah.
Yeah, that's fine. Site one.
when the started the. Okay, we are their substitution.
Yeah.
Tell me we're all set.
Okay. You got the variable to work?
Yep.
Which one did you guys use? Or did you
We actually put a, we had done this the previous go-around, and we put a variable into the project version, or defined the project version using a variable. And then we were able to see the project we created in our repository with that variable.
Okay. Okay. Cool.
So, and this time around, we configured developers into the project.
Right. Okay. So you guys in your other project where you're using those properties, are you defining just like textual information, or are you defining like more build-oriented information?
In our current practice, in our current system?
Yeah, yep, exactly.
What are you doing in the desktop page?
I don't recall defining any I didn't create any user properties, but I know in the desktop vision we track a user-defined property that holds the version number. So I know Mike changes that on a regular basis.
Yeah.
When we're finalizing it.
Yeah. Looks like we are using properties. I'm just looking at one of the products that we have. Looks like we're using properties to define the product version, because we have multiple POMs and we want them all to sync up on the same version.
Right.
We have looks like a web context and things like that we're partially using to determine actually the context of the web app that's deployed. So a few other sort of output-related
Okay.
properties. And we have one property which is called ENV, which points to prod. I don't know if that's a canned property. Yeah. So that that's it. It doesn't look like we're making a very elaborate use of it.
Okay.
And in this one file, we've got maybe 10 plus or minus.
Okay. Yeah, that's insightful. I mean, the reason I usually ask that question is that some of the Ant projects that I've worked on are just like completely overladen with project properties. 50 types of properties, right? 50 properties, and they just become unwieldy to deal with.
Yeah.
So I was some people when they move to Maven kind of adopt the same type of structure because they either don't know, properties exist at the system level or the, OS level or whatever. So anyway, it was just more for my own knowledge. Yeah. Okay. Cool. Well, let's talk about the next little section then. Now that we kind of have a hang of how properties work, we could go create our own, or you guys could go create your own build paths. And now, like in the example, now you could go query, is this a production environment or is this a QA environment or whatever, and then you could create your own custom build structure for that targeted device. A really concrete example is I was doing some work with a with a company, and all of their development was built on, like, all engineers built projects on whatever machine they wanted. So some people had Mac, some people had Linux machines, and some people had Windows machines. And when we built something on a Unix-based system, we would stub out a dependency on an actual Windows DLL file. The production machines were Windows. So what would happen is we had a little deviant path in our Linux, as the OS, some variation of Linux or Unix. We would stub out a different Java native method for that environment versus the production environment. And it was a very easy way to handle that in the build. I didn't have to worry about changing the task that I was invoking to do the build. The build just figured it out. So that's kind of an example where it might be useful. But without going down the path of full-on alternate build structures, we can do some basic build configurations as well in the general build settings of our project. I had mentioned earlier the idea of configuring the compilers, for example, to deal with different source and target levels. So that's the kind of idea here. Or if I want to adopt a different directory structure, I don't want to use source src as my source. I don't want to use classes as my output. I want to use bin. Those types of things I can configure without having to create a huge alternate path. So in other words, I just define my build. In the build tags, define the variations, and I'm good with things. If I were to go, if I were to go create alternate build paths, they would also show up in this build tag. And then the one thing that's a little bit weird is that some of the default configuration that I would have to copy into each alternate path so that the build information makes sense for the particular path. Some of it can be structured as general, kind of global build configuration, but some of it has to be pared down to the alternate path. So again, you guys have the PDF. It's way beyond the scope of our kind of 4.5-hour session. But if you look maybe 190 or 200, something like that, I think you'll find a discussion about alternate build paths.
Okay.
So that's where the, jumping ahead, that's where the extensions piece comes into play. So let me, in the sake of time, I'm going to jump forward a little bit. So this is this I think should be like slide 131 or something in the PDF, but what we're trying to show you here is that anything that's related to a build, whether it's just general information, an extension, or a plugin, I can configure that entity for the specific build. So this is saying, in my particular project, when I am using the compiler, make sure that I compile the source using the 1.6 flag, and make sure that the bytecode that's generated is also for 1.6. Okay, so remember that the default configuration of the compiler comes from my super POM, right? And now I am overriding the default configuration specific to my project, and it only affects my project, if that makes sense. So here's another example of a plugin configuration. Remember that the Surefire plugin, the one that's doing testing, is going to stop when it encounters a test failure. So this little configuration example says, instead of stopping at a test failure, keep processing the tests. So again, right, I'm only defining this build configuration for my specific project. And because I don't have any extensions, there's only one build for my project. And then there's one more to look at. And if you think back to our discussion earlier, I mentioned to you that the way that jar is structured right now is that it does not create a comprehensive jar. It creates, for a standalone application, it just creates a jar as an archive. So if I wanted to flip that jar into a standalone app that's double clickable with a main class and a class path, I could go in and configure the jar plugin. So now if I did that and then I packaged the app, assuming app actually had dependencies on other libraries, they would all be shoved into the jar for me. So the point of those three examples is to show you that it's not very hard to configure the plugins associated with a build. It's just figuring out what configuration the plugin supports by reading the documentation and then implementing it in XML. Questions on those three quick discussions?
We're good.
Okay. All right.
Is there a way to show, if we're using subversion, is there a way to add subversion on the manifest, the tag where you are building from?
That's a good question.
Awesome.
Is there a way to pull out the, if we're using subversion, is there a way to pull out the subversion tag?
Yeah, so you'll have to look. There are a bunch of different plugins dealing with subversion. In fact, you can configure your POM to pull out to do the checkout for you from subversion, and then check in as well.
Yeah, so we configure the POM to pull a specific tag out of subversion.
Right. Yep.
I'm thinking more
or
where it came from. If you look at JBoss, one of the JBoss, you can see the actual tag is there.
Or you can configure the POM to do all your release management for you.
Mm-hmm.
It's not baked into Maven by itself. You have to go get one of the release manager plugins.
Yeah.
And through that you can do configuration for deploying to subversion, kicking off continuous integration tasks, or checking into subversion, kicking off a continuous integration task, all those different things. So it's just a matter of finding the very long answer to your question is that it's just a matter of finding the correct plugin. Because not all the plugins have the same support for in terms of configuration.
Yep.
It's kind of an ambiguous answer. I know that. I get that. But if you went to, part of the reason is that if you went and looked at the Maven repository for plugins, I don't know, there's maybe 1,000. I don't know what the exact number is, right? So I obviously don't have a mental inventory of every single plugin and its configuration.
Okay.
So let's talk about resource filtering. Hopefully it'll pull up for us in a second. So remember when we looked at the compile and the test compile phases, there was, in that big lifecycle definition, there was the process resource and process test resources. So if I have resources called out in a resource directory that I want included in my packaging, I can use this resource filtering mechanism. Hopefully, as Java developers, it's pretty easy for us to identify what resources are and why we might want to use them. So we're not going to spend time on that. By default, resource inclusion happens automatically as long as I have something in the correct resources directory. The inclusion of the resource in the package happens automatically. It's the filtering piece that does not happen automatically. And by filtering, I mean you can have bean shell notation in your .properties file that is resolved to an actual value as part of the build. So what you would need to do is basically just enable resource filtering in your POM, and they're pretty easy to do. Again, resource inclusion is already there, but the filtering piece you would need to turn on. So the idea again, right, is that I can process a file differently for my production push versus my local development push. So there's a more comprehensive POM, and all that we're trying to show you here is, again, yeah, I can turn on filtering. It's not a big deal to do that. When I work with filtering, I will probably want to control what is included and what is not included. So there's a wildcarding convention that, if you've ever worked with Ant, should be very straightforward. This is going to say grab any text file in any directory within my resources or its children, and grab any RTF that's in my resources or its children. So that's pretty easy. I can also exclude files, right? So if for some reason I've got a .java file in my resources directory, obviously don't package that with my artifact. So those should look very, if you've done Ant, those should look very familiar to you. Okay, and then the last major thing that we were chartered to go through is just a quick discussion about how I can use the archetype plugin to build different types of projects. So this isn't so much a discussion about Maven per se. At this particular point in time, we've talked through Maven life cycles. We've talked through how to do basic configuration of Maven, and then now we're moving our conversation to say, how do I create different types of projects? That's really what it's about. So for this discussion, really what we're looking at is the archetype plugin and some of the capabilities of the archetype plugin. We have already used the create goal, and the create goal just used a template based on whatever we defined and created a project for us, or a POM for us. There are, I don't know, maybe 400 or 300 and some odd different types of archetypes available. So if I wanted to look at all of those different archetypes available to me, instead of saying Maven archetype :create, I could say Maven archetype :generate, and then that's going to give me a kind of a cursor-based C-driven, feeling like it's written in C-driven menuing system where I can pick a template. Create from project. Let's say that I built a project structure and I built a POM, and I want to make that POM available to everybody else in my organization as a predefined archetype. What I can do is this create from project goal. It's basically going to reverse engineer a well-formed POM into a template, and then I can publish that, which is cool. Crawl is just a way to tell the plugin to, hey, go refresh yourself from the archetype repository, because it's not going to do that automatically. So we've already done the create example. That should be pretty straightforward. So let's look at another example. Another example is for us to create a web application. I'm going to start off by using archetype generate. Archetype generate is going to give me a list of archetypes. I pick from that list of archetypes. And then I just generally answer the questions that archetype template asks me. So this particular one, it's hard to see, but in the list, whatever the value was for menu item 87, that's the one I chose. And then it says, hey, there are 5 different versions. Which version do you want? So I chose version 1. And then you'll see, hey, it's going to go ahead and download the archetype for a web app. It's going to ask me all this information relating to my project coordinates. And then it's going to go ahead and snapshot and build. I'll show you the output. It's going to build what would be a simple web-based application in Java for me. So the key there is that it's very much like where we started with archetype create. It's going to build a POM for me. It's going to build a project structure for me, and that at that particular point in time, it's my responsibility, to go tweak the POM in whatever way I need to. So once I've done that in the context of a web app, because a web app's packaging unit is a war instead of a jar, that's going to affect the life cycle, right? So the life cycle that we had talked about before was a life cycle for the jar. War has got its own defined life cycle, which is slightly different. The biggest difference, right, is that it's going to package up a .war file to include the classes in the meta-inf or the web-inf classes directory versus just a flat directory. So it's got some alternate behaviors. And then the other stuff that's somewhat interesting is that when I'm dealing with a war deployment, obviously I want to be able to test my war in a servlet container. And the next few slides, we won't go through them in a lot of detail, but the next few slides just show you how you could configure either the Jetty plugin, and then you could deploy and run Jetty, or you could configure the Tomcat plugin and deploy and run your web app in Tomcat. Okay, so let me pull up a shell a second, and let me share my desktop here. And make sure this thing is up. Second. Okay. Okay, now theoretically you should see a bash shell.
Yep.
Yep, okay. Okay, so the point of this is that if I wanted to create something other than a jar, I type Maven archetype generate. So let's go through this a second. Excuse the scrolling. So you can see here that Maven downloads a bunch of different things for me from repositories. What it's basically doing is it's downloading all the metadata for all the well-known archetypes. Then it's indexing those. It's continuing to do that. Okay, so then it's indexing those into its own repository. And you'll see when it shows you the menu for the repository whether that archetype is remote on the repo server or if it's local. I don't have any, there aren't going to be any local archetypes available to me, but that's the kind of idea. So it gets a catalog entry of all those available archetypes, builds this menu, and then I pick from the menu what type of project that I want. So let's just see. Let's just find one here a second. Trying to find just a plain. Okay, so let's do EJB Java EE6 258. Get back to the bottom of my list here. Go ahead, put in 258, like we saw on the slide. Pick the version, so I'm going to do 7. This is default. Now you'll see that it's downloading. Now it's actually downloading the physical jar that describes the project structure and the POM for that project structure. So the first thing it does is it downloads all the metas for the catalog entries, and then it actually downloads the archetype template. Test. EJB test. So go ahead and say, yeah, it's a snapshot version. Okay, sure, it's the test. And then it's just going to double confirm for me. Okay, and now theoretically, I should have in this directory something with my artifact name, EJB test. Right, and then in there, I've got my POM. And then if I were to look at my source directory, you'll see I've got a test directory, right? I've got my meta-inf directory, so on and so forth. So all that to say is it's pretty easy to have Maven generate a starter project for you. The hardest thing, to be honest, the hardest thing is looking at this list of 403 different versions and picking the correct one. That's the hardest part. Questions on that? Okay. So that was kind of a whirlwind tour of Maven. What I'm gonna suggest is that definitely spend some time going through the rest of that PDF. If it turns out, Derek, that you guys have a set of questions that would be easier to answer as a group, let me know and we can schedule another 15, 30-minute WebEx or Ready Talk if we need to.
Okay.
Otherwise, there are some labs baked into that handout, and assuming you guys follow the convention of how the book is structured, the labs keep building on top of each other. So you should be in a good place to continue on through those labs moving forward.
So I have a couple questions.
Okay.
So sometimes I'm working on a project, and I'll add a dependency, and to Apache or JBoss or something. And sometimes Maven is sort of magically smart enough to go onto the internet.
Thank you. Please stand by.